In this lab, we will be establishing the relationship between the concentration of sugar in aqueous solution with the solution's density. As you can see, it is important to wear long pants, closed-toed shoes, and these highly fashionable goggles as with any other experiment in the lab. Each group member will take a volume of the stock solution in the pipette and release different amounts into the volumetric flask. Here is the stock solution in the volumetric flask. The stock solution is a concentrated solution, in this case 20%, that will be diluted to a lower concentration for actual use. The lab member then fills the flask with the dyed blue water up to the 25 milliliter mark. This is the solution after filling the rest of the flask with water, which is called a dilution. This is the process of decreasing the concentration of a solute by adding more solvent. In this case, the solute is the stock solution to create the dilution. To get the volume of the stock solution from a pipette, the lab member reads the initial volume of the bottom of the meniscus with a 0.01 uncertainty, and it is recorded. Then they release some of the solution into the volumetric flask before reading the final volume in the same way. To find the volume of the stock solution, the lab members will subtract the initial volume from the final volume. The meniscus is a concave curve at the top of a liquid, which happens because the molecules of the liquid are attracted to those of the container all the way around. To accurately measure the volume, hold the glassware at eye level and read from the bottom of the curve. Here is an example of how the student would read a volume from the graduated pipette. The graduations are 0.1, so there is a 0.01 uncertainty. In this example, the volume is 1.29 milliliters if you read from the bottom of the curve. Each lab member will repeat these steps with different volumes of the stock solution to create differently concentrated dilutions. This first table shows how we found the volume of each stock solution trial by subtracting the initial by the final volume. We also found the volume of water used by subtracting the stock solution volume by the total volume of the dilution in the 25 milliliter volumetric flask. Using this information and the concentration formula, we multiplied the stock solution concentration by the stock solution volume, then divided it by the final volume to get the final concentration. After the lab is completed, it is important to clean up the workspace, which includes wiping up the table, rinsing, washing, and drying the glassware, and putting all the supplies away. Even while cleaning up, it is necessary to wear those iconic goggles.